Hi, Assalamualaikum. We are from group 4A1 and today we want to present our mini project which is Sustainable Hollow Concrete Brick. Before getting started, let's introduce ourselves first. My name is Muhammad Haziq Hanan bin Sapili.
My name is Muhammad Amar Daniel bin Farid Irman.
My name is Muhammad Hadi Darish bin Kamar Zaman.
So, this is our video outline. There are introduction, background study, methodology, findings, discussion, conclusion and reflection.
Let's begin into introduction part. First thing first is to produce a sustainable hollow concrete brick by replacing some amount of natural aggregate with a sustainable material while maintaining the standard brick dimension. Second, to investigate the effect of sustainable materials on the physical properties and compressive strength of the hollow concrete brick through laboratory testing. Third part is the project includes material selection and preparation, concrete mix preparation, brick fabrication, curing and quality evaluation to assess the performance of the produced bricks. Fourth part is the use of sustainable aggregate helps reduce the consumption of natural resources, minimize construction waste and lowers environmental impact. The last part of introduction is this project supports sustainable construction practice by promoting environmentally friendly building materials and contribute to Sustainable Development Goal SDG 9 Industry, Innovation and Infrastructure. Okay, so now let's move on to the second subtopic of this video, which is background study. The first background study I will talk about is characteristic of glass waste. First, it is selected as a sustainable aggregate due to its abundance and non-biodegradable nature. Second, it is mainly composed of silicon dioxide exceeding 70% with calcium oxide and sodium oxide. Third, it is high hardness and compressive strength, improve the mechanical performance of concrete. Fourth, low water absorption and impermeable surface help maintain good workability. Last part is fine glass particle fills internal voids, reducing porosity and improving brick quality. Second part of background study is justification for 20% replacement. 20% replacement was selected based on finding from previous research. Second, provide an optimal balance between structural performance and environmental sustainability. Third, maintain compressive strength while reducing the consumption of natural aggregates. Fourth, divert more glass waste from landfills compared to lower replacement levels. Last part is glass bottles were collected, cleaned, crushed and sieved before being incorporated into the concrete mix.
For methodology, it have 4 parts. For the first one, it is material selection and preparation. Ordinary Portland cement, sand, gravel, water and glass paste were selected as the materials for the concrete mix. Glass waste was collected from local recycling stations. After that, it been washed, crushed and sieved to obtain a suitable aggregate size. Cement and natural aggregates were stored in a dry location to prevent moisture absorption before mixing. The laboratory work area was cleaned and organized to ensure a safe, systematic and efficient working environment. Next, we go to concrete mix preparation. A concrete mix containing 20% crushed glass waste as a partial replacement for conventional aggregate was prepared. All materials were accurately weighed according to the mix design before the mixing process. Cement 0.69 kg, sand 1.62 kg, gravel 2.408 kg, and glass paste 0.602 kg were thoroughly mixed to achieve a uniform distribution. Clean water 0.48 kg was gradually added until a uniform concrete mix with acceptable workability was obtained. After that, we go to brick fabrication process. The fresh concrete mix was cast into standard hollow concrete brick molds in multiple layers. Each layer was mechanically vibrated to eliminate air voids and achieve optimum compaction. The top surface was leveled and finished using a trowel before the bricks were left in the molds for 24 hours. The bricks were then demolded and water cured to ensure proper hydration and strength development. And lastly, for methodology, we go to testing and evaluation. After 7 days of curing, the brick was tested to evaluate its physical and mechanical properties. The brick dimensions and weight were measured to determine its density. A compression testing machine was used to determine the ultimate load and compressive strength. The test results were analyzed to evaluate the suitability of using waste glass as a partial aggregate replacement in hollow concrete bricks.
Next part of this video is results table. So now I will present to you about our result of our concrete hollow brick compression test. First, our brick number is 4 and 1. Weight of our brick before curing is 2.828 kg, while after curing is 2.837 kg. The length of our concrete is 223 mm, while the width is 101 mm and the depth is 77 mm. And the ultimate load after go into compression machine is 74,800 Newton. Next is gross area. To find gross area, we need to times the length with the width, which is 223 mm times with 101 mm until we get 22,523 mm square. Next is the hollow area. The hollow area we need to length times width times 2 because there are 2 hollow in our bricks, which is 65 mm times 40 mm times 2, and we will get 5,200 mm square. Next is the net area. To find net area, we need to gross area minus with hollow area, which is 22,523 minus with 5,200, and we will get 70,323 mm square. With this, we can find our compressive strength, which is load over with net area, with is our ultimate load is 174,800 Newton over with 70,323, and we will get 10.091 megapascal.
For the discussion, the 20% glass with hollow concrete brick successfully achieved the project objective by reaching a compressive strength of 10.091 MPa, exceeding the 7.0 MPa safety standard under a 174,800 Newton load, proving its valuability for real construction. Critical analysis revealed this superior strength is due to the hardness of crushed glass replacing gravel and fine glass particle acting as a dense filler. Additionally, a curing-induced weight gain from 2.828 kg to 2.837 kg confirmed optimal water absorption for type C hydration, which was enhanced by the smooth texture of the glass that improved compaction and eliminated strain, reducing air void. By substituting 20% of depletable natural aggregate with non-biodegradable with glass, this project directly advanced SDG 9 industry, innovation and infrastructure and promote a circular economy. Linking this high-performance physical finding with ways of diversion from landfills, this study proved that sustainable hollow brick are highly viable, eco-friendly alternative for the green construction industry. In conclusion, this project successfully proved that a 20% crushed glass replacement produced viable hollow concrete brick, reaching an impressive 10.091 MPa strength with 174.8 kN load after 7 days. Reflecting on the process, hands-on laboratory execution deepened our understanding of concrete technology and material behavior, showing how the glass hardness and filler effect successfully optimized structural density. This eco-friendly method directly advanced SDG 9 by reducing landfill waste and preserving natural aggregate. However, key limitations include evaluating only a single 20% replacement level, testing a single sample without a control break, and relying on short-term 7-day curing. To improve future study, it is recommended to evaluate varied replacement ratio 10%, 5% and 25%, include a standard control mix, and expand testing to 28 days strength, water absorption and density. Ultimately, this finding confirmed that with glass is practical, high-performing and sustainable alternative for the green construction industry. For our reflection, this mini project has been valuable learning experience that greatly improve our practical laboratory skill and teamwork. Through the hands-on process of preparing material, mixing concrete, casting mold, and testing the brick, we gain a deeper understanding of concrete behavior in civil engineering. We'll also realize the importance of green construction, as our brick successfully achieved a strength of 10.091 MPa using 20% recycled glass waste. This project taught us that engineering solution can be both highly functional and environmentally friendly, directly aligning with SDG 9 to promote sustainable infrastructure.